Hi everybody, today we're going to be going over ionic bonding again, but to that we're going to add covalent bonding and metallic bonding and facts about each one. First, to review, ionic bonding forms when there is a transfer of electrons. In other words, the metals lose the electrons and the nonmetals gain the electrons, and therefore the metals become cations with a positive charge and the nonmetals become anions with a negative charge. So what we have there, as you can see in the picture, is a structure that is a alternating structure between positive and negatively charged particles. So in this example, this is the gray circles are sodium Na1+, and the green circles are chlorine Cl1-. So electrons in the valence shell are completely given up because metals have low ionization energy, and that allows an electrical attraction to the negative ion to pull electrons from the positive cation to stabilize itself. So we end up with a structure, again, made of positively and negatively charged ions that are trapped in a structure like that when ionic bonding is solid, when it's a solid. However, when ionically bonded compounds are melted or they are dissolved, then the ions are free to move, and then ionic compounds can conduct electricity. In covalent bonding, this forms where two or more nonmetals share electrons. And so you can see the picture of two atoms are together and they are each sharing one electron. And there is no crisscrossing of charges because there are no charges. Nothing loses an electron, nothing gains an electron. There are no charges in covalent bonding. Why does this happen? Well, this happens because nonmetals have very high electron negativities and ionization energies, and they are unlikely to either gain or lose electrons. So as a result, since both nonmetals are both unlikely to gain or lose electrons, then they share electrons instead so that they can complete their octet rule and have 8 electrons in their outermost shell. In metallic bonding, this occurs when metallic atoms are melted together, forming a mixture known as an alloy. And what forms is a lattice or a structure of positively charged atoms known as cations with electrons that are free to move about the structure, being equally attracted to all of the positively charged particles at the same time. But because the electrons are able to move and are mobile, this allows things like electrical and heat conductivity. It allows metals to be malleable, meaning they can be shaped, ductile, meaning they can be pulled into long wires, and it allows them to have that lustrous, shiny appearance. Okay, so a quick comparison. There are 3 types of chemical bonds, and ions or ionic bonds are made of metals and nonmetals. Metallic bonds are made of metals with electrons shared amongst all of them, and then covalent bonds are where nonmetals are sharing only the valence electrons. So you see a good example of all of the different kinds of bonds there. All of these should have been notes that you were taking. So at this time, I would like you to see, can you fill in any of this chart? Please go ahead and write this chart into your notes at this time and see if you can fill in all the parts. Once you have done that, I'm going to ask that you click to the next slide and see the result. How did you do? If you did not do so well, please change your table that you have written into your notes so that you have all of the parts that you need so that you have a good understanding of both metallic and ionic and covalent compounds. And I'm going to move this because I feel like the bottom you cannot see here. The thing that you cannot see at the bottom is that boiling points and melting points are high both in metallic and ionic bonding, but they are low in covalent bonding. Okay, thank you, everybody.